College Algebra, Module 4, Topic 4.2, Linear Inequalities. Introduction to Inequalities. An inequality results whenever the equal sign in an equation is placed with any one of the symbols. This one is known as less than or equal to, greater than or equal to, less than, or greater than. Some examples of inequality include x is greater than 3, which means all numbers that are greater than 3. X plus 4 is less than or equal to 1 minus 2x. Xy minus x is less than x squared, and 5 is greater than 1. Objective 1 is interval notation. Write each solution set and graph it on a number line, then write the solution using interval notation. Well, interval notation is a way that we write the shaded portion of a graph using the starting point and the ending point. So for the first example, x is less than 4. If you look at a number line, we know that it's all numbers that are smaller than 4, which would be this side of your number line. Because the inequality sign is less than, that means it does not include the 4. So what we're going to do is we're going to put an open circle on 4, meaning it does not include 4, but it includes all numbers to the left of 4. Now in interval notation, you always read the graph from left to right. So starting at the left, you notice that the graph goes on to infinity in the negative direction. So for interval notation, we say that the graph starts at negative infinity and it goes up to 4. Because it does not include 4, we're going to put a parenthesis on 4. The second example, x is greater than or equal to negative 9. We're going to draw our number line. We're going to start with negative 9. Now this time, because you want to shade numbers that are greater than or equal to negative 9, we know we're going to shade numbers to the right of negative 9 on the graph. But this time, because it's greater than or equal to, we're going to put the closed circle, meaning that the solution does include the negative 9. For interval notation, we start on the left, we come across the shading begins at negative 9, but because it includes negative 9, we put a bracket. And then the shading goes all the way to the right, so we say that it goes up to infinity. The third example, negative 3 is less than x is less than or equal to negative 1, basically means that x is greater than negative 3, but less than or equal to negative 1, which means x is between negative 3 and negative 1. So for our graph, we locate negative 3 and negative 1 on the graph. Because it's greater than negative 3, we're going to do an open circle on negative 3. It's less than or equal to negative 1, so we're going to put the closed circle on negative 1, and then we're going to shade everywhere between. Interval notation, going from left to right, the shading starts at negative 3, does not include it, so we put a parenthesis. It goes up to negative 1, it includes it, so it's a bracket. Just be careful, this is not an ordered pair when we're doing interval notation. This is the interval between negative 3 and negative 1. Some examples of interval notation. The first example is the between that we just did. Because both the inequalities were less than, we're going to use parentheses on both of those. And on the graph is everywhere between negative 2 and 2. The second example, negative 1 is less than x is less than or equal to 3. We use a parenthesis for where the less than was. We use a bracket for the less than or equal sign. Notice the third example, they were both or equal to's, so we've got both brackets when we talk about interval notation and the graph. Notice on the fourth example, it's all numbers greater than negative 3, which means the graph goes off to the right, so your interval notation is going to end with the infinity. The next example, because it's less than and the graph is going off to the left, the interval starts with negative infinity and then goes up to that point. Let's do some examples. Write each inequality in interval notation. So for this first example, we start our shading at 2 and we end at 5, so the interval would be from 2 to 5. Because it's a parenthesis or an open circle, we put the parenthesis at 2. Because it's a bracket or a closed circle, then we put the bracket on 5. On the second example, remember we said negative infinity is all the way to the left, so the graph would start at negative infinity and go up to 2. Remember, when writing interval notation, the endpoint uses a parenthesis when the endpoint is not included in the solution, and it uses a bracket when the endpoint is included in the solution. Just to refer this back what you used to, if it's less than or greater than, that's the open circle, that's the parenthesis. The less than or equal to, greater than or equal to, that was the closed circle, which is now the bracket. The second note says infinity and negative infinity always get a parenthesis. So if the graph is going back to the left, then your interval notation starts with negative infinity and it goes up to whatever the number is. Or if the graph is going off to the right, then you have your number going up to infinity, which ends in a parenthesis. Objective 2. Compound inequalities. A compound inequality is two or more inequalities joined by the word and or the word or. And means choose the solution set that is included in both inequalities. So x is less than a and x is greater than b means all x's that are greater than b, less than a, or between b and a. This is called set intersection. So in this case, we would have two numbers on our number line. X is less than a, which means it's from here back this way. X is greater than b, which means it's from here this way. Because it's an and, you're looking at the graph that satisfies both of those. Well, you see right here in the middle, that's the only one that satisfies both of the graphs, which means that x is between b and a. For the second one, or means to choose the solution set that is included in any of the inequalities. So for this case, our graph would look like x is less than a, which would be back to your left. For the second part, x is greater than b, which means this part. Since it's an or, that means it's just which is in the left hand or the right hand side of the graph, so that would be your total graph. Now this is called set union, and usually we represent set union with the little U symbol. Let's do some examples of compound inequalities. Write each solution set and graph it on a number line. Then write the solution using interval notation. So for the first one, x is less than 2 or x is greater than 5. So we're going to have our number line. We're going to put our numbers 2 and 5. Make sure your numbers are in order from left to right. X is less than 2 is an open circle on 2 shading numbers to the left. X is greater than 5 is an open circle on 5 shading to the right. So interval notation, because there's two parts of the graph, because it's an or, our interval notation is going to have two parts. So the first part starts at negative infinity and ends at 2. Or the second part starts at 5 and ends at infinity. Now for the second example, x is less than 3 or x is less than negative 5. Let's put our numbers on there. So we've got 3, we've got to go in order. So we've got negative 5 and then 3. So x is less than 3 is from here all the way back. X is less than negative 5 is from here all the way back. Now because it's an or, notice if you pick a point back here, it satisfies both of them. If you pick a point in here, it only satisfies the x is less than 3, but because it's an or, that's okay. But notice there's no point up here that satisfies either of the inequalities. So for the OR graph on this one, it's basically everywhere less than 3. So your interval notation would be negative infinity up to 3. Now, had that been an AND, then it would have just been this little piece right here from negative 5 down to negative infinity. Let's do another one. X is greater than or equal to 4 and greater than or equal to 8. Same thing, so we'll put our 4 and our 8 on our number line. X is greater than or equal to 4 is from 4 to the right. X is greater than or equal to 8 is from 8, remember these are closed circles because it's or equal to the right. Now because this is an AND, notice no point in here is going to satisfy both of them. Point between 4 and 8 only satisfies the first one. So because it's an AND, we're only looking at this last piece over here. So the interval notation means it starts at 8 and ends at infinity. Objective 3. Linear inequality in one variable. Well, a linear inequality in one variable is an inequality that can be written in the form ax plus b is greater than 0, where a is not equal to 0. This was just like our linear equation that we did earlier. Now notice in this I've got greater than, but this also works for less than, greater than or equal to, or less than or equal to. So which of the following are linear inequalities? Well, the first one, because there is an 1x variable and it's to the first power, then yes, this one is a linear inequality. We could get it in the form if we subtracted 3x from both sides and we subtracted 2 from both sides, we would get 2x plus 2 is less than or equal to 0. The second one, because it contains an x squared, the x squared disqualifies it from being linear. The third example, because we have an x in the denominator, that disqualifies that one. That is also not a linear inequality. And then the last one, it looks linear. We could go through and multiply it out. So if we distribute, we would get 1x minus 3. For the second part, we would get plus 8x plus 4 is greater than 5. Notice how there's one variable, it's to the first power. So yes, this one is going to be a linear inequality. We could combine like terms. We've got 1x plus 8x, which gives us 9x. We've got negative 3 plus 4, which is plus 1. We could set that equal to 0. We could subtract 5 from both sides, so we get 9x minus 4 is greater than 0. But really, all you've got to check is that you have one variable, and that variable's to the first power. Objective 4. Solving linear inequalities. We solve linear inequalities the same way we solve equations, by getting the variable on one side of the inequality sign and a number on the other side. Now if you'll remember the steps that we use for solving an equation, the same number may be added to or subtracted from both sides of an inequality. Both sides of an inequality may be multiplied or divided by the same positive number. Both sides may be multiplied or divided by the same negative number. However, and this is the catch, you must change the direction of the inequality sign. Let me say that again. If you multiply or divide an inequality by a negative number, then you must change the direction of the inequality sign. Everything else works exactly like solving an equation would. Alright, let's do some examples. Solve the inequality, write the solution set in interval notation. So we want to get x on a side by itself. So we're going to go through and add 5 to both sides of the inequality. So we get x is greater than or equal to 2. Once you get your inequality, let's look at the graph. X is greater than or equal to 2. That means it includes 2. So we're going to put a closed circle. Shade numbers greater than 2. So we're going to shade to the right. So our interval notation is bracket 2 to infinity, parenthesis. Now, you can use your calculator to check your calculations and check the graphing. We do not suggest using your calculator to solve an inequality, only to check it. The reason is it's not extremely accurate, meaning if the answer is 2.1 or 2.2, you're probably not going to be able to tell the difference. And it does not show what happens at the end point, meaning it does not tell you open circle, closed circle, parenthesis, or bracket. So let's check this one on our calculator. To check your inequality, we're going to go into y equals, and we are going to put y1 the left side, which was x minus 5. Then our inequality sign, you see right here, third one down where it says math, we're going to go to second math, which is test. And our inequality sign is greater than or equal to. Well, notice your inequality sign greater than or equal to is number 4. And then we're going to put in the right side, which was negative 3. I'm going to go to zoom 6 just to square up our window. So when we hit graph, you notice that it's got the numbers from 2 to infinity shaded. You see what I mean about it's hard to tell if that's 2.1 or 2.2 or even 1.95. It's hard to tell, but at least we can look at that and know that it's somewhere pretty close to 2, and everything to the right of that should be shaded. So for the next example, solve the inequality, write the solution set in interval notation. Now notice we've got a few more steps here. So the first thing we're going to do is distributive property to clear out the parentheses. So we would get 4x minus 8 is greater than 6x plus 4. Now to get all the x's on one side, we are going to do minus 6x on both sides. So we get negative 2x minus 8 is greater than 4. Numbers to the other side, so we're going to add 8 to both sides. So we get negative 2x is greater than 12. Last step, we want to get just x by itself, so we're going to divide by negative 2. Put 3 stars here. Remember, anytime you divide both sides by a negative number, you have to change the direction of your inequality sign. So we would get x is less than negative 6. So our graph, here's negative 6. We want to shade numbers to the left of negative 6. So we're going to shade back to the left. Notice this sign is the same as our arrow on our graph if the x comes first. So that sort of gives you a hint which way we're shading. So our interval notation starts at negative infinity, goes up to negative 6, does not include negative 6. So our interval notation is parenthesis negative infinity to negative 6 parentheses. Second example, solve the inequality, write the solution set in interval notation. Well, this time we've got a fraction, so we can clear out our fractions if we multiply both sides by the LCD, which in this case would be 5. 5 goes into 5 once for both of those, so we end up with x plus 1 is greater than or equal to negative 10. To get x on a side by itself, we're going to subtract 1, so we get x is greater than or equal to negative 11. Our graph, here's negative 11. It's greater than or equal to, which means it's going to be a closed circle on negative 11. And then we're going to shade to the right, which would give us an interval notation of bracket negative 11 to infinity parenthesis. Another example, same thing. We're going to distribute first to clear out the parenthesis. So we would get negative 3x minus a negative 12 is greater than or equal to 2 plus 2x, which would give us negative 3x plus 12 is greater than 2 plus 2x. Same thing, I'm going to get all the x's on the left side because I think it's a little bit easier to graph. Subtract 2x from both sides, so we get negative 5x plus 12 is greater than 2. We're going to subtract 12 from both sides, so we get negative 5x is greater than negative 10. To get just x, divide by negative 5. Now remember, when you're solving inequalities, you divide by a negative number. That's your flag that says watch out. So we get x is less than, because you've got to change the direction, 2. Now, let me show you something real quick. Let's go back up here to this point right here. Negative 3x plus 12 is greater than 2 plus 2x. Let's say we wanted to put the x's on the other side. So what would happen is we would go plus 3x plus 3x. We would get 12 is greater than 2 plus 5x. Now when we go minus 2, we get 10 is greater than 5x. Now notice this time we don't have to worry about dividing both sides by a negative number, but we get 2 is greater than x. Well, it's a little bit tougher to graph 2 is greater than x than it is to do x is less than 2. So if I were working it this way, what I would probably do is flip the whole thing. X is less than 2. So now when we graph it, there's our 2. Less than means it's an open circle. Less than 2 means we're going back to the left. So our interval notation is parentheses negative infinity to 2 parentheses. Another one. Solve the inequality. 3x plus 1 over 5 is less than x plus 2 over 3. Now remember, to solve an equation containing fractions, you multiply both sides by the LCD. So for our problem, the LCD is 15. So we can multiply both sides of the equation by 15. Well, the first piece, that's like 15 over 1, so we could cross cancel. 5 goes into 5 once, 5 goes into 15 3 times. Second side, 3 goes into 3 once, 3 goes into 15 5 times. So we've got 3 times 3x plus 1 is less than or equal to 5 times x plus 2. And now we're going to solve it just like we have been. Use distributive to get rid of the parentheses. Get all of the variable terms on one side. Now we're going to put all the number terms on the other side. Now we want to get just the variable on the side by itself. Now notice on this one we're going to divide by 4. Well, it's okay to divide by a positive 4. We don't have to worry about flipping the sign. But we get x is less than or equal to 7 over 4. So for our graph, less than or equal to 7 over 4, we're going to shade 7 over 4 and shade back to the left. So interval notation is negative infinity to 7 over 4. The negative infinity gets a parenthesis. The 7 over 4 gets the bracket. Now back to compound inequalities. To solve a 3-part compound inequality, your goal is to get x by itself in the middle. Remember, whatever you do to the middle piece, you must also do to the other 2 pieces. So to solve negative 8 is less than or 2x is less than or 6, we want to get just x by itself in the middle. Well, we have 2x in the middle, so we're going to divide both sides by 2. Well, whatever you do in the middle piece, you must also do in the other pieces. So we get negative 4 is less than x is less than 3. X is between negative 4 and 3. So we've got negative 4, 3. It's less than on both sides, so they're both open circles, and we're going to shade in the middle. So interval notation would be parenthesis negative 4, 3, parenthesis. And keep in mind, this is not an ordered pair. It's the interval between negative 4 and 3. Let's do another one of these. To solve this inequality, first we want to clear out the fractions. So we're going to multiply every piece by 7. In the first piece we get negative 7 times 7, which is negative 49. In the second piece the 7's are going to cancel, so we get 1 minus 4x. And then on the last side we get 7 times 12, which is 84. Now we want to try and get just the x term in the middle, so we're going to subtract 1 from all three pieces. So we get negative 50 is less than negative 4x is less than or equal to 83. Now we're going to divide all three sides by negative 4. Not only are the numbers going to look sort of ugly, but remember we're dividing everything by a negative, which means we're going to have to flip the sign. So we've got negative 50 divided by negative 4, which would be a positive 25 over 2. Flip the sign so it's greater than. The middle piece is now x. Flip the next sign is greater than or equal to negative 83 over 4. Now anytime you've got this three-part inequality, it always needs to go from smallest to largest. So what we're going to do is flip the whole thing. We've got negative 83 over 4 is less than or equal to x is less than 25 over 2. So when we graph it, we've got negative 83 over 4 with a closed circle here. We've got 25 over 2 with an open circle here, and our answer is all x's between those. So interval notation would be bracket negative 83 over 4, comma 25 over 2, parentheses. Now let's go back to solving inequalities using your graphing calculator. Now remember the one I showed you earlier, I told you it's not a real good way to solve it because you couldn't get exact, but it was a great check. Well, now I want to show you how you can use your calculator to actually solve these. Okay, now this time what we're going to do is we're going to go up to y equals, but we're going to enter the left side of the equation as y1. We're going to enter the right side as y2. So the left side would be negative 4x minus 3, and the right side would just be 5. Now notice, we want to find where y1 is less than y2. So we're going to go into graph. There's y1, there's y2. First thing we need is this intersection point. Okay, so we're going to do second trace, which is calculate. Number 5 is where they intersect. Enter for the first curve, enter for the second curve, enter because we do not want to guess. So that tells us that the solution, or the intersection, is at negative 2. Now we want where y1, which was the slanted line, is less than y2. Because the y values are the height, basically, or the ups and downs, we want to know where the y1 is below the y2, which starts at this negative 2 and is everywhere to the right. So for our solution, it would be from negative 2 to infinity, because if you picked any point from here to your right, that is from negative 2 all the way over, the y1 is going to be below y2. This one would be pretty tough to do pencil paper, but we should be able to do it fairly easy on our calculator. So what we're going to do is we're going to let the left side of the inequality be y1. We're going to let the right side be y2, and we're going to look to see where the first line is greater than or above the second line. So we start up here at y equals, and we're going to say the square root, which is the second square of 2. Make sure you close that parenthesis, times x. The second one, y2, would be 10.5 minus the second square root of 3. Close that parenthesis. Okay. And when we press graph, notice we get two lines. They intersect right here, so that's the boundary point. Now remember, we are looking where y1 is greater than y2, which means we're looking where the first line is above the second line. So when we find where the first line is above the second line, it starts right here. So we're going to go second trace, which is calculate, number 5 where they intersect, enter for the first curve, enter for the second curve, enter to guess, and we get that the lines intersect at 3.34 if you round to the nearest hundredth. So starting at 3.34 to the right, the first line is above the second line. So our interval notation would be 3.34 to infinity. Now, let's go back and talk about the difference of the other way we were doing it. The other way, we would go to y equals, and we wouldn't have a y2, we would just enter everything on the y1. So we're going to go to second math, which is test. Square root of 2 times x is greater than 10.5 minus the square root of 3, close that, times x. Now, this time notice when we graph it, we only get the number line, okay, which is somewhere between 3 and 4, shaded to the right, which sort of verifies what we did the first time. Now, we could do trace and see if we're getting a little close. Notice as we hit trace and then as we go over, see the x value is 2.9, 3.1, and then it jumped up. So we know our solution is somewhere between 3.19 and 3.4. We're pretty confident that this is the right answer. Objective 5 is applications. For this example, the linear function f computes the distance y in miles between a car and the city of Toronto after x hours, where the graph of f is shown in the figure. So what this means is, as the time increases, as the number of hours increase, notice the distance in miles also increases. So the first question says, is the car moving towards or away from Toronto? Well, after 1 hour, it's 75 miles away. After 2 hours, it's about 87 miles away. After 3 hours, the car is 100 miles away. So the car is actually moving away from Toronto. The second part says, determine the times when the car is between 75 and 150 miles from Toronto. Notice your distance here is 75. Your distance here is 150, so from time 1 hour to time 7 hours, the car is between 75 and 150 miles from Toronto. So we could write that as 1, 7, and I'm going to use brackets because at 1 hour the car is equal to 75 miles away. I'll use the brackets to show that it works for 1 and 7. You are now ready to do the homework for Module 4, Topic 4.2 in my math lab.